So finally, today is the day when the transformer for LireAI is finally coded. Although it was, this is not something new again. Again, the tokenizer was also one of the things which has been done before, very basic of the basic things. Transformer been done before, basic of the basic things. But what about transformer, okay? What is transformer, first of all? So a transformer is a neural network, okay, which understands like how humans talk, okay, and the meaning of words. Like it's basically a translator for computer, okay. And when we give an input to the computer, that's like language, right? Like we are telling something to the computer to do, and it takes words, right? We type it in. So to understand those words, right, for the model to understand those words, we use a neural network which is called transformer. You can call it, it's more like the spice of the LLM, okay? So it's it's the main component without which the large language models wouldn't be able to work, okay? So like for the past few days I was not uploading videos. There was a reason, because I was working on this transformer for a long time. And actually there's a paper out there, by, I think it's by Google, but there's a lot of engineers who have worked on this paper who are working from Google, like working for Google. So the name of the paper is called "Attention is All You Need." Okay, and they created this transformer using a thing called self-attention. I won't go in the details of it because if you want to go in the details, the paper is already out there in the on the on Google, and you can just read it. Okay, uh, so it took me some time to understand that paper. Okay, it was very hard to understand at first, and then the thing started to make sense. And once the paper started to make sense, I started developing it. I started developing the transformer, started working on the coding part. So let me show you, what I have achieved so far. So that's the whole code. That's how it looks like. I mean, this is the result, but let's go up and let me show it to you. So this is, the whole code. Uh, I have to like do some documentation as well so that I know, where everything is. Okay, so what about epoch and loss? Okay, so the loss here you see is the loss of data. Okay, so this is the loss of data which has happened during epoch 1. And now what is epoch? So an epoch is like a number of iterations. Okay, now what is number of iterations? Let me explain you by this example. Like, um, what if there's one delivery man in a logistic company, okay, and he has to deliver 100 courier in a day, okay, 100 items. So think of every trip for every delivery, okay, and the company policy is that you can only deliver one item in one trip, okay. So if you have to deliver the second product, you have to come back to the company, take the product, and then go to the house. So that takes like 100 times going out, 100 times coming in, right? So every time you go out once, that's called forward pass. And every time you come back again to the company, it's called backward pass, okay? Uh, Sort of like a zip up, zip down, zip up, zip down. So one epoch is one zip up and down, okay? The forward and backward pass together, it becomes one epoch, okay? So in this scenario, right, when the model, okay, it runs through the data, okay, it goes forward pass and comes back, that's called one epoch, okay. And the loss of data during the first epoch was 9.3386, which is very bad, okay. But after doing 20 epochs, the loss reduced to 2.5837, which means that uh, by you know running it again and again, the model got better, and the model stopped, like the loss of data became much more lesser as we went on with the epochs, and the model can generalize better now. Okay, it can generalize things better, it can create patterns, it can see patterns and generalize them easily. So that's what loss going down as we go up in the epochs means. Okay, so the epoch goes up and the loss goes down, but the main goal for us, like for me right now, is to get to the epoch of 3 to 4 within the first 0 to 5 epochs. Okay, sorry, so to reach the loss of 0 to 3 or 3 to 4, 3 to 4 between 0 to 5 epochs. So that's the goal right now. And yep, so I mean, I can say it's the second breakthrough so far for Lyra. The transformer done. Right now, I'm working on another version of transformer, which is much more, much more complex than that, because I mean, there's some errors, which I have to take care of. Let me show you some. So yeah, right now there are some, issues with the code here, but that's not a problem because uh, I mean, I'm working on it. So this will be done in another 1 or 2 weeks, and one of the main begin like what one of the main reasons also for this to have a bad performance is the hardware, because in the paper, wait, let me just open up the paper. uh, yep, yep. So even in the paper, right, the paper was created with using 8 NVIDIA P100 GPUs, and I'm just using this Mac Mini. Okay, so that's why the performance is also very low. But again, this is the place where I need funding, I need more cash so that I can invest in those things and prepare better models. But as you know, it's just me doing it, so we'll keep it low key for now. But once I hit maybe another 5 6 breakthroughs, and then once I have a prototype which I can release in the market and also can show to the investors that this is a prototype, if you want to spend money on it, by all means. But yep, so I will see you whenever the future progresses happen. I know I haven't been uploading for some days, but again, the entropy, right? I'm just trying to figure out a lot of things at the same time. Yep. So I will see you later. Bye bye.